For years, something strange has been happening at the edge of our solar system. A group of icy objects far beyond Neptune aren't behaving like the rest. They're drifting in the same direction, their orbits strangely aligned, as if something massive is silently guiding them. And no, it's not Neptune. It's not Pluto. It's something much farther out, heavier, and completely hidden. Astronomers call it Planet 9, a mysterious world potentially 5 to 10 times the size of Earth, orbiting so far that sunlight barely reaches it. But here's the real question. Has Planet 9 finally been spotted, or are we chasing shadows across the void? Back in 2016, astronomers Mike Brown and Konstantin Batygin stumbled upon something unusual. They weren't hunting planets. They were simply mapping distant objects at the solar system's edge. These weren't comets or planets. They were extreme trans-Neptunian objects, frozen rocks orbiting beyond Neptune. But instead of scattering randomly, many of these objects formed neat clusters, all tilted similarly and pointing in the same direction. That shouldn't happen naturally. Something invisible must be tugging on them. Brown and Batygin ran the numbers. If a hidden planet was responsible, it had to be massive, at least 5 times Earth's mass. Maybe up to 10, and orbit hundreds of times farther from the Sun than we are. Neptune, by comparison, is only 30 times farther than Earth. Planet 9 wouldn't just be far. It would dwell in a part of space we've barely explored. They published their findings with careful math, showing how such a planet could explain the clustering and even the odd tilts of some smaller, distant bodies, and thus began the hunt for one of the most elusive objects in modern astronomy. Telescopes around the world began scanning the skies, sifting through old images, analyzing archived data, and even inviting amateurs to join the search. Every new extreme trans-Neptunian object seemed to reinforce the theory. Some moved in reverse orbits, others tilted strangely. But the math always pointed to one conclusion: a massive, hidden world lurking in the darkness. But there was a catch. No one had actually seen Planet 9. Every prediction, every scan, every attempt came up empty. The theory was compelling, but proof remained elusive, and that's when skepticism set in. Not everyone agreed that clustering alone was enough evidence. Some scientists pointed out that the small number of objects and the narrow field surveyed could create an illusion. Imagine walking through a forest with a flashlight pointed in one direction, of course. You'll only see the trees illuminated in that beam. Could the alignment of these icy objects be the same kind of bias? Meanwhile, others explored alternative explanations. Maybe a massive disk of small bodies was influencing their orbits. Or passing stars in the solar system's youth had stirred things up. Some even suggested that gravity might behave differently at these extreme distances. Planet 9 wasn't the only explanation, but it was the simplest that matched the math. For nearly a decade, the hunt pushed forward. Astronomers revisited old infrared data from satellites like IRA, AARI, and WISE, hoping something faint might have been captured unnoticed. Thousands of slow-moving dots were catalogued, most of them galaxies or noise, but a few were intriguing. Could one of these be Planet 9? Maybe, maybe not. One particularly exciting discovery emerged from careful analysis of archival data in 2025. A faint object moving slowly over decades. It wasn't bright, but it was there, radiating just enough heat to stand out in infrared. At first glance, this seemed like exactly what astronomers had been waiting for. But the orbit didn't match. It was tilted over 120, moving in a retrograde orbit opposite most known planets. In other words, it wasn't Planet 9, but it was something new. Something that deepened the mystery of the outer solar system. Then came another surprising discovery. This time from freshly observed objects. In 2017, a distant dwarf planet named 2017 or 2001 was catalogued. Its orbit stretches nearly 1,600 astronomical units from the Sun, far beyond Pluto's 49, and its path is extreme elongated, tilted, and unusual. Could this be proof of Planet 9? At first, it seemed possible. Planet 9 was predicted to fling objects into these high-eccentricity orbits over millions of years, but closer analysis revealed it didn't fit the original clustering. Instead of confirming the pattern, it challenged it. Each new object in the outer solar system either strengthens the case for Planet 9 or complicates it. And 2017 OR2001 did the latter. So if Planet 9 is real, how did it get there? Forming a massive planet hundreds of times farther from the Sun, then Earth seems impossible. Beyond Neptune, the solar system thins. There's just not enough material to build a world that size. One leading idea is that it formed closer in, perhaps near Jupiter or Saturn, and was flung outward during the chaotic early days of the solar system. Gravitational interactions could have ejected it into a stable, elongated orbit bound to the Sun but far from view. Another possibility is even more dramatic. Planet 9 was never ours. It could be a captured planet, stolen from another star during the Sun's early life in a dense stellar cluster. Simulations suggest capturing a planet in this way was rare, but not impossible. Either scenario explains a massive planet with a strange tilted orbit, exactly what we're hypothesizing for Planet 9. After years of searching, the tools we have are finally reaching a turning point. Enter the Vera C. Rubin Observatory in Chile. Unlike most telescopes, Rubin doesn't focus on one target at a time. Its massive digital camera surveys the entire southern sky night after night, capturing faint, slow-moving objects that older surveys would miss. The observatory's legacy survey of space and time LSST could detect objects hundreds of astronomical units away, as faint as magnitude 24. If Planet 9 exists within these limits, Rubin should find it. And if it doesn't, that's a revelation to it would strongly suggest the planet is smaller, farther, or simply doesn't exist. Other efforts continue in parallel. Citizen science projects like Backyard Worlds, Planet 9 enlist volunteers to comb through telescope data, spotting objects that algorithms overlook. Upcoming space telescopes like Nancy, Grace, Roman, and Euclid will refine our understanding of the outer solar system and improve our maps of background stars. And there's always the possibility that Planet 9 has already been seen buried in old data, hidden behind the galactic plane, or simply dimmer than expected. Rubin, however, represents the first opportunity for a sustained, systematic, higher-resolution search of the most promising region. For the first time in nearly a decade, we're approaching a potential resolution. Planet 9 may exist, or it may be a mathematical ghost we've been chasing for years. Either way, the search itself has revealed just how little we truly understand about the solar system's outer reaches. Each strange orbit, each faint object, reminds us that space is more mysterious than our models can predict. The hunt for Planet 9 isn't just a scientific pursuit, it's a journey into the unknown. A quest that may finally answer one of astronomy's most tantalizing questions. Is there a massive hidden world lurking in the shadows at the edge of our solar system? Even as we wait for Rubin to turn its gaze southward, Planet 9's potential existence raises other questions. What would a world this far from the Sun look like? Cold, dark, and silent. A frozen giant orbiting in near total darkness. The sunlight. There is barely a fraction of what we feel on Earth, so any surface features would be hidden in eternal twilight. Its atmosphere, if it has one, could be a thin haze of hydrogen or methane, slowly drifting across a frozen, rocky landscape. Imagine a planet so isolated that earthly telescopes have only the faintest hint of its presence. And yet, its gravity silently choreographs the dance of distant, icy objects. And if it's out there, Planet 9 isn't just some scientific curiosity. Its discovery would rewrite what we know about planetary systems. We'd have a rare glimpse into how planets can survive ejection, capture, or extreme orbits. It might show us that our solar system isn't the orderly, well-behaved neighborhood we've always imagined, but a chaotic, crowded, and surprising place. If other stars have planets flung into distant orbits, maybe rogue worlds drifting between stars are far more common than we realize. Our understanding of planetary formation and dynamics could change forever. Then there's the human side of the hunt. Astronomers like Brown and Badajian have spent years chasing a shadow. Every new object found, every archival survey analyzed, feeds hope or disappointment. Amateur astronomers trawl through online databases, searching for tiny anomalies. The thrill of possibly being the first human to spot Planet 9 drives a quiet obsession in labs, observatories, and even backyard telescopes. It's a hunt that combines patient analysis, luck, and relentless curiosity. And it's this very combination that has kept the mystery alive for nearly a decade. But let's not forget the curveballs. Even when something new appears in the data, it rarely solves the puzzle cleanly. Objects like the 2017 OR2001 dwarf planet remind us that the outer solar system doesn't follow our expectations. It operates on its own terms, influenced by ancient gravitational pushes, past stellar encounters, and cosmic chaos. Every discovery both illuminates and complicates the picture. Planet 9 might exist, but it might also be just the tip of a larger iceberg of speculation also thrives here. Some researchers wonder if multiple smaller hidden worlds are influencing the ETNOs rather than a single massive planet. Others suggest that maybe Planet 9 exists in a position so perfectly aligned with the galactic plane that it's effectively invisible to our instruments. Or perhaps it drifts in a slow, unpredictable orbit, moving in ways we haven't accounted for in our models. Each possibility adds intrigue and keeps astronomers scanning, computing, and debating. Looking ahead, the Vera-C-Rubin Observatory isn't just a final test, it's a revolution in how we observe the sky. For years, telescopes focused on individual targets, but Rubin can monitor massive swaths of the southern sky night after night, year after year. LSST will capture trillions of data points, tracking slow-moving objects with unprecedented accuracy. For the first time, we can catch those faint drifters that have eluded discovery for decades. And with each passing night, the odds of finally spotting Planet 9 or discovering something even stranger grow higher. Even if Rubin comes up empty, the search doesn't end. Upcoming missions like the Nancy Grace Roman Space Telescope will refine the map of distant objects. Citizen scientists and machine learning algorithms will comb through mountains of historical data, uncovering patterns and anomalies invisible to human eyes. And every new discovery teaches us something about the solar system we never knew. Planet 9, whether real or imagined, has already transformed our understanding of the cosmic frontier. So what's next? In the coming years, we might finally know the truth. Planet 9 could emerge from the shadows, slowly drifting into view, confirming nearly a decade of speculation. Or we may conclude that the planet doesn't exist at all, and the outer solar system's strange alignments have a more subtle explanation. Either outcome would be monumental, because the story of Planet 9 isn't just about one hidden planet, it's about the limits of observation, the thrill of scientific discovery, and the mysteries that lie at the very edge of our solar system. For now, we wait. Telescopes scan, data is analyzed, and the icy objects beyond Neptune continue their silent dance. Somewhere in the darkness, Planet 9 may be out there raw, maybe something even stranger. Either way, the search has already shown us that the solar system is far more mysterious than anyone imagined. And that's a story that will keep scientists and all of us watching the skies for years to come, even as we wait for the Rubin Observatory to start its survey. Planet 9 remains one of the most tantalizing mysteries in modern astronomy. Imagine a world orbiting hundreds of times farther from the Sun than Earth, a frozen giant silently influencing the motion of icy rocks millions of kilometers away. Its gravity is invisible, yet precise enough to shepherd distant objects into a dance we can only detect after years of observation. And it's this invisible pull that makes astronomers certain something massive exists, whether it's Planet 9 or another unknown force entirely. Some scientists think Planet 9 could be a planet-sized relic from the solar system's youth. During the early days, planets formed in a dense, gravitationally turbulent environment. Gas giants jockeyed for position, exchanging momentum like cosmic bumper cars. A newly formed Planet 9 could have been flung outward in this celestial shuffle, escaping close encounters with Jupiter or Saturn, but settling into a distant, stable orbit. It wouldn't be easy to spot it move slowly, so slowly that a human lifetime would barely notice its motion across the sky. And yet, its presence subtly shapes the paths of everything around it. Others suggest a more dramatic scenario. Planet 9 might never have been ours. The Sun formed in a crowded stellar nursery, surrounded by dozens of other young stars, each with their own developing planetary systems. In that chaotic environment, planets were often stolen, exchanged, or ejected entirely. Simulations show it's plausible that our Sun captured a wandering world from a neighboring star, rogue planet pulled into orbit hundreds of astronomical units away. This would explain its strange tilted path, completely misaligned with the rest of the solar system. Planet 9's orbit could be a signature of a stolen world, a cosmic trophy that quietly reshaped the outer solar system. While theorists debate its origin, observational astronomers continue the hunt. The Vera C. Rubin Observatory is poised to be the most powerful tool yet. Unlike earlier telescopes, Rubin doesn't zoom in on one small patch of sky. It captures the entire southern sky repeatedly, night after night. Over a 10-year survey called the Legacy Survey of Space and Time, it's the first time we'll have a consistent, deep, and systematic look at the regions where Planet 9 is most likely hiding. If the planet is there, Rubin should see it, slowly drifting across the backdrop of stars, revealing itself in infrared and visible light. And yet, even if Rubin fails to detect Planet 9, that result would be just as compelling. It could mean the planet is smaller, darker, farther away, or hidden behind the crowded background of the Milky Way. Or maybe our models of its orbit are wrong. Either way, science advances. Each null result refines our predictions, narrows the search, and improves our understanding of the outer solar system. Then there are the discoveries that complicate the picture. Objects like the dwarf planet 2017, OR2001, remind us that the outer solar system does not conform neatly to our predictions. Its orbit is extreme, elongated, and tilted in a way that defies the clustering pattern Planet 9 was supposed to explain. And yet, it exists. Something powerful placed it there. Perhaps it's a smaller, hidden world, a remnant of early solar system chaos, or a clue to unseen forces at work. Every new discovery forces scientists to question their assumptions, challenging the idea that there is a single dominant Planet 9. Speculation is rampant. Some researchers propose that instead of one massive planet, a swarm of medium-sized objects could be shaping the ETNO's orbits collectively. Others wonder if a combination of past stellar encounters and long-term gravitational nudges are sufficient to explain the alignments. Every theory adds intrigue, but none yet provides definitive proof. The mystery deepens, keeping astronomers scanning the skies and analyzing every new object that drifts into view. And then there's the human factor, the obsessive curiosity that drives discovery. Astronomers have devoted years to this search, studying faint points of light across decades of data. Citizen scientists sift through online databases, algorithms comb through terabytes of archived surveys, and every new object sparks discussion, debate, and excitement. The thrill of potentially being the first human to detect Planet 9 drives people to look deeper, think harder, and imagine the impossible. Even the tiniest hints in archival data can change everything. Infrared surveys from decades ago, designed to study stars and galaxies, have revealed mysterious heat source, slow-moving dots that don't match known objects. Could one of them be Planet 9? Or perhaps another unknown world, lurking unseen, shaping the motion of distant icy bodies? Each lead, however faint, becomes a spark in the search for answers, reminding us that the solar system may be far stranger than we imagined. Looking forward, Rubin's repeated surveys combined with upcoming missions like the Nancy Grace Roman Space Telescope and Euclid will sharpen our view of the outer solar system. They will provide unprecedented depth, resolution, and sky coverage, helping astronomers rule out false leads, confirm intriguing candidates, and map the distant reaches with precision never before possible. And while some possibilities may be ruled out. New mysteries are certain to appear because the outer solar system is full of surprises waiting to be discovered. But what would Planet 9 really be like? We can only speculate. Its surface, if solid, could be a frozen desert of rock and ice. With temperatures far below anything experienced on Earth, sunlight there is barely a fraction of what we feel, and the atmosphere, if it exists, might be a thin haze of methane or hydrogen. Any potential atmosphere would drift silently across the planet, whispering secrets of a world that has been isolated for billions of years. And yet, despite its remoteness, its gravitational presence is undeniable, subtly shaping the architecture of our solar system in ways we are only beginning to understand. The origin story of Planet 9 is equally fascinating. One leading theory suggests it formed closer to the Sun, perhaps near the gas giants, before being flung outward during the chaotic early days of the solar system. Planetary interactions in the primordial disk could have sent it hurtling into a distant elongated orbit where it settled into the slow, silent path we theorize today. Computer simulations support this scenario, showing that 1 in 10 young solar systems might eject a planet into a distant orbit that remains gravitationally bound rather than escaping entirely. Even more dramatic is the possibility that Planet 9 was never ours to begin with. The Sun formed in a dense stellar nursery, surrounded by dozens of other young stars. In that crowded environment, planets were constantly stolen, exchanged, or ejected entirely. Simulations suggest that a passing star could have had its planet captured by the Sun, placing it on a highly inclined, distant orbit, the kind of orbit that aligns with some of the anomalies we see today. If true, Planet 9 would be an interstellar refugee, a cosmic migrant captured billions of years ago, silently influencing our solar system from the shadows. While theorists debate its origins, observational astronomers continue the search with increasing intensity. The Vera C. Rubin Observatory, located in Chile, is poised to be the most powerful tool yet. Unlike traditional telescopes that focus on small patches of sky, Rubin captures huge swaths in a single shot and does so repeatedly over 10 years. Its Legacy Survey of Space and Time, LSST, will monitor the entire southern sky night after night, catching even the slowest moving, faintest objects. If Planet 9 exists within the predicted orbit and brightness, Rubin should detect it, finally lifting the curtain on a mystery that has eluded astronomers for nearly a decade. And yet, even if Rubin fails, that would be just as significant. Non-detection would force astronomers to reconsider Planet 9's characteristics. Perhaps it is smaller, darker, farther out, or hidden behind the dense star fields of the Milky Way. Every null result narrows the possibilities and helps refine models of the outer solar system, proving that the hunt itself, even when it fails to find the planet, is reshaping our understanding of the cosmos. Meanwhile, the outer solar system continues to surprise. Objects like 2017 or 2001 defy the predictions of the original Planet 9 theory. Its orbit is extreme, highly elongated, and dramatically tilted, completely breaking the clustering pattern Planet 9 was supposed to explain. And yet, it exists. Something powerful shaped its path. Whether it is another undiscovered massive object, past stellar encounters, or subtle gravitational nudges accumulated over billions of years, each discovery deepens the mystery. Every new object forces astronomers to reconsider assumptions and accept that the outer solar system may be far more chaotic and complex than originally thought. Speculation continues to flourish. Some scientists propose that instead of one massive planet, a swarm of smaller, hidden objects could collectively influence the ET. Others suggest that galactic tides or ancient stellar flybys alone might be sufficient to create the observed alignments. Every new theory adds intrigue and keeps astronomers scanning, analyzing, and debating. Human fascination is an important part of this story. Astronomers and citizen scientists alike are driven by the hope of being the first to spot Planet 9. Years of patient observation, data crunching, and sky surveys are fueled by curiosity and obsession. Even the tiniest anomalies in archival data can ignite excitement. leading researchers to reanalyze decades-old infrared surveys, searching for subtle clues that might have been missed. Every faint, slow-moving dot in the data becomes a potential treasure, a tantalizing hint of the unknown waiting to be confirmed. Infrared surveys from satellites like IRAS, Akari, and WISE have revealed mysterious heat sources, slow-moving points that do not match known stars, galaxies, or noise. Could one of them be Planet 9? Or perhaps another unknown object entirely? Each lead, however faint, sparks discussion, debate, and hope. These glimpses remind us that our solar system is far more mysterious than the orderly diagrams in textbooks. Suggest the Vera C. Rubin Observatory will change the game. By systematically observing the southern sky, it will identify slow-moving objects invisible to earlier surveys. For the first time, astronomers will have the tools to detect objects, like Planet 9, with confidence. But the search doesn't stop there. Upcoming missions, like the Nancy Grace Roman Space Telescope and Euclid, will refine our understanding of the outer solar system, improving background maps, and helping to identify faint, distant objects that might otherwise go unnoticed. Ultimately, the story of Planet 9 is about more than just a hidden planet. It is about the limits of human observation, the thrill of discovery, and the mysteries that lie at the edge of our solar system. Whether Planet 9 exists or not, the hunt has already revealed just how dynamic and complex this distant region is. Each new discovery, each faint dot, and each unexpected orbit teaches us something about the vast frozen frontier that surrounds our sun, and so, the search continues. Telescopes scan, algorithms process, and citizen scientists comb through terabytes of data. The outer solar system remains a place of extremes, surprises, and unanswered questions. Somewhere out there, Planet 9 or something just as strange waits to be found. And for the first time in nearly a decade, we may finally be close to discovering what's really out there. The early discoveries that sparked the hunt are as mysterious as the planet itself. Extreme Trans-Neptunian Objects, or ETNOs, weren't behaving randomly, they were clustering, tilting, and aligning in ways that seemed impossible without a massive, unseen influence. Mike Brown and Konstantin Bettigen noticed this in 2016. Their calculations suggested that something enormous, perhaps 5 to 10 times the mass of Earth, was out there, a planet so distant that sunlight barely reaches it, so faint that it could hide in plain sight for centuries. But the hunt hasn't been straightforward. Over the years, telescopes have scanned predicted regions with no success. The planet has eluded even the most powerful instruments. Every time a new ETNO is discovered that fits the predicted pattern, excitement surges, but just as quickly, anomalies emerge that challenge the theory. Objects like 2017 OR2001, with orbits vastly different from the predicted clustering, force astronomers to rethink assumptions. The outer solar system refuses to conform neatly to our expectations. Some scientists propose alternative explanations. Perhaps a swarm of medium-sized objects collectively shapes the ETNOs, or maybe ancient stellar flybys subtly altered their paths. Others speculate that galactic tides or even unknown gravitational physics could be at play. Each hypothesis adds intrigue, but none yet provides definitive proof. The mystery deepens with every discovery, and with every unanswered question, the fascination grows. Imagine the possible scenarios if Planet 9 exists. Its surface could be a frozen wasteland, illuminated only by the faint glimmer of distant sunlight. Its atmosphere, if any, might be a thin frozen haze, drifting silently across the planet in near-eternal twilight. Its gravity, though invisible, would shepherd icy objects across the solar system, shaping the dance of distant bodies millions of kilometers away. It's a planet that influences, without revealing itself, a master of subtlety in the vast darkness of space. Theories about its origin are equally compelling. One suggests Planet 9 formed closer to the Sun and was flung outward during the chaotic early days of the solar system. Another proposes it may have been captured from a neighboring star in the Sun's crowded birth cluster. In either case, its orbit is highly elongated and tilted, a cosmic exile traveling a path unlike any other planet in the system. Simulations show these scenarios are plausible, even likely, under the chaotic conditions of early planetary formation. Meanwhile, advances in observation technology are bringing us closer to an answer. The Vera C. Rubin Observatory, with its massive 8.4-meter Simony Survey telescope and world-leading digital camera, will scan the southern sky repeatedly over 10 years. Its unprecedented depth and coverage make it ideal for detecting faint, slow-moving objects like Planet 9. If the planet exists within the predicted mass range and distance, Rubin could be the first to capture it. And even if Rubin finds nothing, that result will be monumental. It would indicate that Planet 9 is smaller, darker, farther away, or hiding in a region we haven't considered. Every non-detection refines our understanding of the outer solar system and eliminates uncertainties. Null results are as important as discoveries. They shape our search, sharpen our predictions, and guide future exploration. For years, something strange has been happening at the edge of our solar system. A group of icy objects far beyond Neptune are drifting in the same direction. Their orbits are aligned in a way that suggests a massive object is shepherding them into a clustered pattern. This alignment is statistically unlikely without an external gravitational influence. And no, it's not Neptune, it's not Pluto. It's something much farther, much heavier, and completely hidden. Astronomers call it Planet 9, a mysterious world that could be 5 to 10 times bigger than Earth, orbiting so far out that sunlight barely reaches it. And the weird part, there are new signs from old data, new discoveries, and strange objects that might finally point to where it's hiding. Or maybe we've been wrong the whole time. Has Planet 9 finally been spotted? Or is this the biggest scientific ghost hunt of the decade? Let's find out. Back in 2016, something strange caught the attention of two astronomers, Mike Brown and Konstantin Batygin. They weren't looking for a new planet. They were just trying to figure out why some objects in the outer solar system were acting weird. These weren't planets or comets. They were what we now call extreme trans-Neptunian objects, or ETNOs, for short, frozen rocks orbiting way beyond Neptune. But the odd thing was this: many of them had orbits that weren't random. Instead of being scattered in all directions, their paths were clustered. They were all tilted in a similar way, and they all seemed to point in the same general direction in space. That's not supposed to happen. In a stable solar system, small objects that far out should have chaotic, scattered orbits, not neatly aligned ones. The only explanation that made sense at the time: something massive was tugging on them. Something we hadn't seen yet. Brown and Batygin ran the numbers. If this mystery planet existed, it would have to be at least 5 times more massive than Earth, maybe up to 10, and its orbit would be huge. Something like 400 to 800 times farther from the Sun than Earth. For comparison, Neptune is only about 30 times farther than Earth. So, this thing wouldn't just be far. It would be in a part of the solar system we've barely looked at. They called it Planet 9, not just because it would be the 9th planet after Pluto was reclassified, but because no other explanation matched the data. And coming from Mike Brown, the guy famous for getting Pluto kicked out of the Planet Club, this was a bit ironic. But this wasn't just speculation. They didn't claim Planet 9 existed just for headlines. Their paper laid out the math. It showed how the gravitational pull of this hypothetical planet could account for the clustered orbits of these distant objects. In fact, they said it could even explain some tilted orbits of known objects, like the way some smaller planets lean in strange directions. That kicked off a worldwide hunt. Telescopes began scanning the skies, trying to find this invisible giant. Astronomers started going through old data, hoping they might have already captured it without realizing. Even amateurs joined in, using online databases, algorithms, and even citizen science platforms to look for anything suspicious. And for a while, it seemed like the more we looked, the more pieces fit the puzzle. More ETNOs were found. Some of them had similar alignments. A few even had retrograde orbits, moving in the opposite direction from everything else. And again, the math seemed to point to the same idea. Something big, far away, and hiding in the dark. But there was a problem. No one had actually seen Planet 9. Years passed, more predictions came out, and more search areas were ruled out. But every image, every scan, every attempt to spot it, turned up empty. Still, the clustering was real. And every time a new Neptunian object was found that fit the pattern, it gave the theory more weight. At this point, the evidence wasn't proof, but it was strong enough that Planet 9 became one of the most talked about ideas in planetary science. Not because it was exciting, but because it was the only explanation that made the math work. Still, not everyone agreed. And that's where things started getting complicated. The idea of Planet 9 didn't stay unchallenged for long. In science, it never does. As soon as the theory gained attention, researchers around the world started trying to test it. Some tried to confirm it, others tried to break it. That's how science works. If something's true, it should survive every attempt to prove it wrong. So, what did they do? They ran simulations, a lot of them. Using powerful models, researchers recreated the solar system, but this time with a hidden ninth planet far beyond Neptune. They added the right mass, distance, and orbital shape based on what the theory predicted. And in many cases, it worked. The simulation showed the same kind of orbital clustering we see in real data. The weird behavior of those distant icy objects made more sense when Planet 9 was included. But then came the first major pushback. Some researchers, including Samantha Lawler and Jean-Marc Potty, argued that the clustering might not be caused by a hidden planet at all. It might just be a coincidence. Their point was this: the number of objects we're talking about is small, and most of them were discovered by just a few surveys using the same parts of the sky at similar times of year. That could introduce a bias. If you only look in one direction, you'll only find objects pointing that way. It's like standing in a forest with a flashlight, pointing it at one spot and saying, all the trees are in that direction. Maybe. Or maybe that's just where the light's shining. This led to a growing divide. Some scientists stayed confident, saying the clustering was too consistent to be random. Others weren't convinced. They wanted better data, a bigger sample of objects, and wider sky coverage before accepting a whole new planet. Meanwhile, more simulations were being done, not just to support Planet 9, but to explore alternatives. One group proposed that maybe the strange orbits are caused by a massive disk of small objects acting together, a kind of gravitational soup pulling on things in bulk. Another group floated the idea that passing stars in the early history of the solar system might have thrown everything off. And then there's the modified gravity camp. A small group who believe maybe we don't need a planet or a disk at all. Maybe gravity itself behaves differently at large distances. Most scientists don't buy that last one. But the point is, Planet 9 was never the only explanation. It was just the cleanest one that matched the math. And yet, the longer it went unseen, the more critics started asking, if it's out there, why haven't we seen it? That question became louder over time, especially because, despite predictions narrowing down where Planet 9 should be, telescopes kept coming up empty. Huge portions of the sky were searched, and still nothing. The theory wasn't dead, but it wasn't getting stronger either. It was stuck in a strange place. There was still no better explanation for the clustering, but the absence of direct evidence was starting to wear people down. That's where things stood for a while, but then something unexpected showed up. Not in the sky, but in old data from decades ago, and it changed the story. For a theory that started with so much energy, the search for Planet 9 eventually hit a wall, not because the math fell apart, but because the sky refused to cooperate. After the 2016 proposal, astronomers all over the world began scanning the areas where Planet 9 was predicted to be. Brown and Battigan had used models to estimate its orbit. Not an exact position, but a pretty good guess about where it might show up in the sky and how bright it could be. That was enough to kick off a series of targeted searches using the best tools available. Pan-STARRS, the Subaru telescope, the Dark Energy Survey, and even archived data from the WISE mission, but they found nothing. Part of the problem is how incredibly faint Planet 9 would be that exists. It's likely hundreds of times farther from the Sun than Earth is. So, it reflects almost no sunlight. At that distance, even a Neptunized object would be nearly invisible to most telescopes, unless you know exactly where to look. And Planet 9 wouldn't be moving quickly either. It would drift slowly across the sky over weeks or months, which means most software designed to spot fast-moving objects wouldn't even pick it up. Still, the hope was that maybe Planet 9 had already been accidentally imaged by older surveys. They just didn't realize what it was. So, astronomers started digging into archive data from IRA from the 1980s, ARI, a Japanese infrared satellite, from the 2000s, and WISE, a 2010 NASA infrared mission that scanned the entire sky. These surveys didn't spot a planet directly, but they left behind thousands of mysterious heat sources. Small, blurry, slow-moving dots. The problem? Most of those dots were galaxies, noise, or image artifacts. But what if one of them was something more? That didn't stop people from being interested though, because even if it wasn't the Planet 9, it still raised questions. How many unknown objects are hiding in this region? What else could be out there that we've missed? Meanwhile, other surveys kept narrowing things down. In 2021, a team analyzed data from the Ziki Transient Facility, which had taken years of wide-field images of the northern sky. They filtered for slow-moving objects with the right brightness and distance. The result, they ruled out over half, the region where Planet 9 was expected to be, at least for anything brighter than magnitude 21.3. Then CAMEOS 14, a LISIC, known but specialized survey that also found nothing, which meant this. If Planet 9 exists, it either has to be extremely dim,